In this lecture, I will derive only the phase angle of potential transformer. So for deriving the expression of potential transformer phase angle, we have to draw this phasor diagram first, and then accordingly from this figure we will derive it. So what is phase angle? Phase angle is represented as theta. Theta is equal to the angle between the primary voltage and Vp and the secondary voltage when reverse Vs. So theta is the angle between primary voltage Vp and Vs reverse. So if you look in the triangle OAB, the tan theta is equal to AB by OA. Now, so individually we have to write down the expression of AB and OA. So in the derivation of transformation ratio, we have seen that the OA is equal to NVS plus NIS into RS cos delta plus XS sin delta and IPRP cos beta and IPXP sin beta. So now we know OA from the transformation ratio derivation. Now AB is equal to what? So I am writing down the expression of OA again. So delta is the angle between IS secondary current and Vs. So when we reverse the voltage in the primary side, that time it will be NVS and current will be IS by N. The same angle will be there. So this is the expression of OA. Next, here I am drawing the phasor diagram again, so that you can draw it perfectly. So in the horizontal axis this is phi and Vs is leading. The angle between Vs and Is is delta, and I0 is the no load current, and when you take the current in the primary side, that time it will be Is by N. The phasor sum of Is by N and I0 is IP primary current. So when you express the Vs in the primary side, that time it will be NVS. So the drop is NISRS. After that NISXS, it will be E, then IPRP, then IPXP. So this is the Vs. Then we extend the NVS. Then we will draw a perpendicular line from that point. This point is, this is O, this is A, this is B. So from B we will draw perpendicular line. So we note down the different angle. So theta is the angle between Vp and Vs reversed. So this is our objective, to find out the value of theta. See the way I am drawing a line from NISRS towards A, and I'm just practice this drawing. Two perpendicular lines are there. So delta is equal to angle between IS by N and NBS. So this angle will be delta. Now we draw this line so that we can find the value of AB. So beta, now the angle beta, this is also very, very important. Angle between IP and VS reverse. So this angle is beta because this line represents IP, RP, and this one represents the VS. So drawing is very, very important for proving the expression. This point is C and this is E. So this angle one is OCD, another is ECD. OCD is equal to delta and OCD is equal to beta and ECD is equal to delta. The angle between IP and VS reverse. After that, what we will do, see this point is what I am doing, OA line, I am dividing it as 5 segments, OF, FG, GH, HI and IA, and individually I need the values. So tan theta is equal to AB by OA. Now see this figure carefully. What is AB? AB is equal to BF plus FA. So what is BF? This angle is beta. So BF is equal to IP XP cos beta. Then AB is equal to this segment plus I need the FA portion. For that FA portion, I have to write down. You just watch carefully. This area is very, very important for you. So AB is equal to IP XP cos beta plus NIS XS. This portion NIS XS cos delta. Next we have to subtract 2 segments again. So minus this green area, IP RP cos beta IP RP sin beta and NIS RS sin delta. So this is the expression for AB, and I know the value of OA, so I'll put all this thing together in the expression of tan theta. Here you have to note down in the expression of OA, the value of IS, IP, all this current is very small, and the angle are also small. So we can neglect that part, and only we will take NBS. The phase angle theta is very small, therefore both BP and BS can be taken perpendicular to phi, and therefore angle OCD is equal to beta and angle ECD is equal to delta. So here, again I am drawing it here, angle OCD, angle OED. OCD and ECD. So in a copy, just write down it step by step. So what I have already told, NBS, we will take only NBS. So in this expression, what I have done, IP cos beta is equal to IE plus NS, IP plus IS by N cos delta. And in case of IP sin beta, what I have written, IM plus IS by N sin delta. Rest are same. So IE plus A, now IS cos delta if you take common I is cos delta, then RP by n plus x nx xs minus you take common is sin delta so inside it will be RP by n plus nRs. I is cos delta by n xp is the equivalent resistance, no? The equivalent reactance of the primary side it is. So what I have right now, we know xp plus n square xs is equal to equivalent reactance to the primary side. Refer to the primary side. Now Rp plus n square Rs is equal to equivalent resistance, refer to the primary side. Since theta is very small, so theta is equal to 10 theta. So now the final expression, theta is equal to is by n xp cos delta minus rp sin delta plus ie xp plus im rp by nbs. So here what I can write again, xp by n square, then it will be xs. So is by bs xs cos delta minus rs sin delta plus ie xp minus im rp by nbs. See what I have written, xp by n square is equal to xs, rp by n square is equal to rs. Now put these values. xs cos delta minus rs sin delta plus ie xp minus im rp by nbs. This one is the expression for theta. Now I am talking about the phase angle error. So in ideal voltage transformer, there should not be any phase difference between the primary voltage and the secondary reverse voltage. But in practical, there are some differences, and the expression of the phase angle error theta is we already derived it, and accordingly you derive that one. So remember that phase angle error, theta is the angular shift between the primary voltage Pp and the reverse secondary voltage. Thank you for watching, and you practice it so that you can derive it in the examination hall. And this is very important derivations.